diagram of the standing wave. As you can see, the frequency directs in a right angle for a more balanced sound. Axial modes. I'm just going to talk a little bit about axial modes and attempt to do a little equation. Right, yeah. Axial modes. They occur between opposite surfaces. Opposing surfaces. Yeah. So here we see we have the equation here. Right, to start off with, we've got fx and then axial, and then right, c. What c means is c is the speed of sound. And the speed of sound is 344. What if you, because it's got a little 2 underneath, which means you have to divide it by 2. So what you do is you just divide by 2 equals 172, I believe. And that's how you get your first equation there. And x and L in the bracket there. That means x is the number of half wavelengths that fits between the surface. So you would mostly have that as either a 1 or a 2. And L underneath just means the distance between the reflecting surfaces. So what you would do is you would work out c divided by 2, which is 172, and then you would have 1 over your whatever your length is, and then add that times it all together, and that will give you your answer. But as you can see in the axial modes, so if you're standing in the middle of the ring, you see the axial modes are sort of like horizontal, vertical, and sideways. That's axial modes. Tangential modes occur between 4 surfaces. As you can see, you have the reflective frequencies going on right angles and side by side and stuff. What you do for that equation is you would work out. So we've got the speed of sound divided by 2, which is 172, and you would find out well, x equals 1, and you would find the length, and then you would square that, and then you would add y, which would be 2, and you would divide that by the width. I think the width. Something like that. Yeah, the distance between the reflecting surface, and then you square that, and then you would square that, and then you would times that by the speed of sound 172, and that should give you your answer for that one. Talk a little bit about oblique modes as well. They occur between 6 surfaces. Sort of the same really as the other sort of modes. Problem frequencies are normally at around about 250 Hertz. These readings can then be treated with a material with a high absorption and a low frequency, such as sort of wood paneling, as like I was first saying with your resonance absorbers. They'll be really good for sort of your 250 Hertz to absorb all the sound. And then it's just a little graph here, just showing how that would all work out and stuff. But it's bad to have an outline going like this. You would really want sort of a straight line to give it a nice balanced equal frequency. Yeah, that's really the end of my presentation, but I'm just referring back to when we went on to the Yellow Shark trip. Yellow Shark Studios is really amazing inside, and as you can see, like they've got